We treat the date on a birth certificate as a fixed, immutable record of our existence. It's an absolute number, stamped in ink to define exactly how long we've been alive. However, chronological age only tracks the number of times we have orbited the sun. It is completely separate from biological age, which measures the actual, fluid, physical degradation occurring within human tissue. For most of medical history, clinicians lacked a quantifiable way to observe this cellular decay in living patients. They could see the outward signs of aging, but the internal process remained invisible. Relying strictly on the calendar creates a sense of fixed inevitability. It masks our true individual rate of physical decline, making it difficult to see how well our bodies are actually functioning. Scientists discovered methylation, small tags called methyl groups attaching to our DNA over time. To read these signatures, researchers developed algorithms like the Horvath clock and GrimAge. They analyzed thousands of methylation sites to calculate your precise cellular age. These epigenetic clocks predict actual human mortality with a correlation of 0.96 or higher. They offer a much more accurate forecast of lifespan than the year someone was born. Aging has shifted from an abstract concept into a physical footprint left on our DNA. It is a biological record that we can now read and measure with mathematical precision. Recent metrics, like DunedinPACE, have changed the focus from a static age to a real-time velocity. They measure the current speed at which a person is aging at the molecular level. If understanding the speed of your biological aging is a valuable new perspective for you, please like the video and subscribe to help us share more of this research. Certain factors hit the fast-forward button on this clock. Smoking stands as the most severe accelerator identified in the research, pushing biological age 5 to 10 years ahead of a person's chronological age. Chronic psychological stress, which activates the HPA axis, and obesity also drive the clock forward. Excess visceral fat creates systemic inflammation that directly speeds up the rate of DNA methylation. The data also reveals a measurable effect from moderate alcohol consumption. Drinking just 1 to 2 units daily leaves a distinct epigenetic footprint that accelerates cellular decay. Lifestyle toxins and chronic stressors do more than just lower our health. They actively increase the velocity of cellular degradation, removing years of physical integrity. We can also apply biological brakes to this process. High-intensity interval training, or HIIT, is one of the most effective interventions for slowing the methylation clock. A 2023 study in the journal Aging Cell demonstrated that just 8 weeks of HIIT significantly reduced the participants' biological pace of aging. Dietary changes provide similar benefits. In the landmark Calorie trial, humans who maintained a 12% caloric restriction over 2 years showed a measurably slower pace of biological aging. Adopting a Mediterranean-style diet and optimizing vitamin D and omega-3 levels also helps. These interventions provide polyphenols and fatty acids that reduce the inflammation driving epigenetic decay. Quality sleep is also essential. 7 to 9 hours of rest per night provides the body with the necessary window to repair DNA and maintain healthy methylation patterns. Consistent physical and dietary habits function as a biological brake pedal. They prove that the velocity of our aging is a malleable factor that we can influence. Improvement requires measurement. Without a baseline metric, it is impossible to know how your lifestyle is affecting your internal rate of decay. Modern at-home testing now allows anyone to analyze over 900,000 DNA methylation markers from a simple blood sample. This data provides a comprehensive baseline for your health. It reveals your overall pace of aging and the specific biological ages of 11 distinct internal organ systems, including the brain, heart, and lungs. Our daily choices directly govern our biological trajectory, making the aging process a modifiable condition rather than a fixed path of decline. We cannot alter the year printed on our birth certificate. However, by optimizing how we eat, sleep, and move, we gain measurable control over the velocity of our biological decline.